Okay, let's take a look at 10.4. Now 10.4 is just a repeat of 10.2 and 10.3. It's a combination, so you just have to pick out, are you testing for proportion or for mean? Proportion, you're going to use proportion stat. Mean, you'll use t-stat. So random sample, 200 drivers asked if they drive a car manufactured in a certain country. Of the 200, 110 responded they did. Determine if more than half, so we're dealing with proportion, so equals a half and more than half. P-value. Just close it out. That crunch. That portion stat one sample with summary. So we had 110 over 200. Half more than half. P-value 0.077 or 0.079. And so p-value larger than alpha, so do not reject because p-value is greater than alpha. So there is not sufficient evidence. Okay, sample mean this time, so mean. Determine if population mean is different from 26. So equal to 26 or not equal to 26. Okay, p-value. We'll do stat, t-stat, one sample with summary. N is 15, standard deviation 6.3, and sample mean 23.1. P-value is small, 0. Oh, gotta do the hypothesis test. Make sure we got the mean right. 23.1, and then we've got 26 here, and not equal to 26. All right, p-value is 0.096. And that is greater than. So do not reject, p-value is greater than. Always compare your p-value to alpha. P-value is less, reject. If it's greater, do not reject. So there is not sufficient evidence. All right, sample mean again. So here it is. Is the population mean greater than 100? So equal to 100, greater than 100. Test statistic for mean is always going to be t. So we'll look that up. So sample mean 1044. Standard deviation 24.9. Sample size is 40. And we'll do 100 for the claim and greater than 100. .12 p-value 3 decimals 135. So this is large, so do not reject. P-value is greater than alpha. So there is not enough evidence to say the population mean is greater than 100. They do not reject the null hypothesis because the p-value is greater than level of significance. The population mean is not greater than, is not, because we're basically saying that we cannot claim this. So we're saying that the population mean is not greater than 100. All right, so we've got a psychologist obtains a random sample of 20 mothers in their first trimester of their pregnancy. The mothers are asked to play Mozart in the house at least 30 minutes each day until they give birth. After 5 years, the child is administered an IQ test. You can see where this is going. Does playing Mozart have an effect on IQ? It is known that IQs are normally distributed with mean 100. If the IQs of the 20 children in this study result in a sample of 104.1, standard deviation 14, is there evidence that the children have higher IQs than normal? So is the average IQ greater than 100, which is normal? So we'll grab our test statistic and p-value. So sample mean was 104.1. Standard deviation 14. Sample size was 20. So 100 greater than 100. P-value 0.103. So that is larger than alpha. So do not reject because p-value is greater than alpha. So there is not sufficient evidence to conclude that mothers who listen to Mozart have higher IQs, children with higher IQs. Okay, so in 1945, an organization asked 1484 sampled American citizens, do you think we can develop a way to protect ourselves from atomic bombs in case others try to use them against us? 762 said yes. So did a majority, so now we're proportion, so dealing with proportion. And when it says did a majority, that means more than half. Majority is more than half. So greater than half. Well, they could, that the country could develop a way to protect itself. So let's go ahead and get proportion, stat, one sample with summary. And we've got X is 762 over 1484. More than half. .04. P-value is 0.15. All right, so 1.5, that's large, so the p-value is greater, and so we do not reject, and there is not sufficient evidence. So this time, a recent article about individuals who have credit cards, the mean number of cards per person with credit cards is 4. To test this result, a random survey of 60 individuals who have credit cards is conducted. The survey only includes the number of cards per participant. Okay, so the survey, so the results of the survey are attached below. So I guess here's the survey results. Okay, and so what is the variable of interest in the study? Well, that's the number of credit cards. not the type or the number of people or credit score. And that number of credit cards is a quantitative. It's going all the way back to the beginning. Quantitative variable. All right, so here's the researcher's hypothesis. Do results of the survey imply the mean number of cards per person is less than 4? So we're dealing with the mean equal 4 and the mean less than 4. All right, so here's the data, number of cards. So we'll do t-stat, one sample with data. Pick the variable, and we'll do 4 and less than 4 are the hypotheses. So we get 2 decimals minus 0.6. And the p-value 3 decimals is 274.274. And so that's again large. So it's greater than the level of significance, so do not reject the null, and there is not sufficient evidence to conclude that the mean number of credit cards is, and you always go back here, less than 4. Always go back to the researcher's hypothesis. All right, so we've got last question. A genetic experiment involving peas yielded one sample of offspring consisting of 409 green and 163 yellow. At the 0.05 level, test claim under the circumstances 23% of offspring will be yellow. Okay, so since it doesn't say more or less than 23%, so we'll say this is a two-tailed test. Will equal 23, not equal 23. And then we'll get our test statistic here. So we're going to go proportion stat, one sample with summary. Number of yellow is 163. And then the total number of observations, you actually have to add together the 409 and the 163. So 409 plus 163 gives me 572 as the total. And then 23 and not 23. So test statistic 3.12. P-value right one here is 4 decimals 0.0018. And that is a small p-value, so we reject the null hypothesis because the p-value is less than alpha. So what's the conclusion? So the conclusion is that we support this, that the proportion is not equal to 0.23. So there is evidence to support the claim that less than, there is sufficient evidence to support the claim that 23% of offspring will be yellow, because we're saying in the researchers that it's not equal to 23%. So 23% will be yellow. And what did, just curious, what was our sample? Let's think about this one. What was our sample statistic? 28. Now we got 28. And if we support that it's not 23, which we are, then that would mean what? That would mean that the claim that there is sufficient evidence for the claim that 20%. So we reject the null. There is sufficient evidence to support the claim. Yeah, always go with the. This one is worded kind of strange. There is sufficient evidence to warrant rejection of the claim. Oh, they're rejecting the null. That's what they're doing. They're just saying that there is enough evidence to reject the null. They're not actually positively claiming the researchers. So this one here is slightly different than the others. Hope this helps. See you on the next video.